Myself, Sayee Tambole, a student of class 10C from Dnyanada English School. I am here to talk about the topic modern periodic table. I hope this demonstration will help you to understand this challenging topic of the modern chemistry. So, let us begin. First of all, let's have a look at two individuals who contributed significantly in the modern periodic table. That is Henry Moseley and Dmitry Mendeleev. Dmitry Mendeleev, he realized that the chemical and the physical properties of the elements are related to their atomic masses and hence arranged all the elements in such a way that the elements with similar properties fell into one group. And Henry Moseley, he, instead of arranging them according to their atomic masses, arranged them according to their atomic number, and hence this made a huge difference. This is the periodic table of the elements which we are going to study today. Turning now to the importance of modern periodic table. It is very easy to summarize all the elements with the help of modern periodic table. The elements in the modern periodic table are arranged in a sequential manner and in an informative array. The modern periodic table is also considered as the most important chemistry reference. Now, finally we will move towards the properties of the modern periodic table. There are total 7 rows in the modern periodic table known as periods. The period number indicates the number of shell in the constituent element. The number of shell remains the same throughout the period while adding electrons will increase in its atomic number simultaneously. The periods we studied before are grouped into 4 categories on the basis of the elements they possess. Like the first group, the first period is called as the shortest period because it consists of only 2 elements, that is hydrogen and helium. The second and the third period are called as the short period. They consist of 8 elements each. The fourth and the fifth period are called as the long period and have 18 elements each. The sixth and the seventh period have 32 elements each and called as longest periods. Let us study few examples to clarify our concept. Our first example here is of hydrogen, which is denoted by the symbol capital H. As it is represented in the first period, it will have one shell. Our second example is of carbon, which is represented in the second period and hence it has 2 shells. Our third example is of silver, a lustrous metal, which is represented by capital A and small g. And as it is represented in the fifth period, it will have 5 shells. The next part of our topic begins here. The vertical columns which are marked in this image from 1 to 18 are called groups. All the elements in the same group will have same valence electron, that is, same number of electrons in its outermost shell. As the group number increases, the number of electrons increases simultaneously. Now, let's study few examples. Our first example here is of first group, that is, which consists of elements hydrogen, lithium, sodium and potassium. All these elements will have one as its valence electron, that is, one electron in its outermost shell. The second example is of the second group, and the second group consists of 6 elements, and all the 6 elements will have 2 as its valence electrons. But we should mention here that the group number is not equal to the number of electrons in the outermost shell, that is valence electron. Like in group number 13, there can't be 13 electrons in its outermost shell, like 13 valence electron. Instead, it has 3 valence electrons. In the group number 18, all the elements except helium will have 8 valence electrons, but helium will have 2 valence electrons in its duplet state. Now, we will study few specialities of the modern periodic table. Like in the group 1, all the elements are the alkali metals except hydrogen. Hydrogen is not the alkali metal. All these elements are highly reactive. The group 2 consists of all alkaline metals that are alkaline earth metals. These are called alkaline earth metals because they are obtained from earth crust. The elements from group number 3 to group number 12 are all transition metals. All the elements in group 18 are called noble gases. The elements in group number 17 are all halogens. The elements here represented in the orange color are all basic metals. The elements here represented in green color are all metalloids. Elements here represented in blue color are called nonmetals. Now we will summarize all what we have learned with the example of oxygen. Oxygen is very important to the living beings, and oxygen is represented in the second period. So naturally it will have 2 shells, and as it is represented in the 16th group, it will have 6 electrons in its outermost shell, that is 6 valence electron. Its valency will be -2, and as oxygen is represented in blue color, it is a non-metal. So thank you. I hope you like this video.